Should we move on to probability? Yeah? Alright. You've got to do a lot of reading here and interpretation. One marble is chosen at random from a bag of marbles. If the probability of the marble being red is 1, which statement is true? Now, one of the ways it's easiest to help you work out which of the correct answers it is thinking about 1, think about it as a percentage. Right? We're good at doing percentages. How do I convert 1.00, how do I convert that into a percentage? How do you convert any number into a percentage? You multiply by 100, don't you? That gives you 100%. You guys know what 100% means. It's definitely going to happen, right? So if you're definitely going to get a red marble, that means all of them have to be red. Because if one of them wasn't red, then the chance would not be 100%. Which of these events has the highest probability? Probably the easiest way to go through is think about all of them and work them out as fractions. Think about which is the biggest fraction, right? A head on a coin. How many options are there on a coin? There are 2, heads and tails. So the head is 1 out of 2. Rolling a 2 on a normal die, how many options are there? How many faces are there? There are 6. So this is a 6. Choosing Monday at random, there are 7 days. Choosing E from the vowels, that's 1 out of 5 vowels. So you can see this number has the smallest denominator, which means it's the biggest number. That's why it's A. Okay. Sophia tossed a fair coin 10 times, 3 heads, 7 tails. What's the probability that the next toss will be a head? Okay, now this is a bit of a sneaky question. It's a trick question, right? They add in all this information. 10 times, 3 heads, 7 tails. But the crucial thing you need to realize is it's a fair coin. It's fair. That means that it's equally likely to get a head or a tails every single time. It's kind of the... if you've heard of the gambler's fallacy, you know, if someone's gambled, they're gambling and they've lost many, many times, okay, on a game. They might think, oh, I'm more likely to win for the next one. But it's not true. The odds are still the same. Come in.
This one, because it was so easy. It was like, number 5, 6-year-old. I had to look at like 5 years ago.
Okay. Yeah, you can only do the one answer, unfortunately. So, a different one?
No, so this question, Corey, I had to look at it about 5 times.
Yeah, it's designed to be tricky. Yeah. It's designed to see if you really understand how does probability work, right? It's all about, well, what's the likelihood at any given time, and it's a fair coin. So that's why it's always 50-50. Let's go on to the next one.
Wait.
Choose the correct phrase to complete the following sentence. I think most of you went pretty well on this. 4/5. It's more than half, right? So it's not this. It's not certain that it'd be 100% like we've looked at before. It's one of these. Which one is it closest to? Well, since it's more than a half, right? It's not unlikely to happen, it's likely to happen. So that's how you get B. Alright, let's have a look at these spinners. Make sure the whole thing's on there.
This is the one I did A and B.
Yeah, just the one answer. Alright, let's have a look. Jim and Kevin playing a game using a spinner. A player wins when the spinner stops on his colour. Jim always chooses green. Kevin always chooses white. Which spinner should Kevin choose so that he has the greatest chance of beating Jim? Kevin beats Jim. So that means we want green to beat white. Okay? Does that make sense? Wait, did I do it the wrong way around? Other way around. Other way around, sorry. White beats green. Okay, so therefore what we want is for, in relation to each other, we want white to be biggest, right? Now, have a look. Look at the look at where the spinner is, right? Does that matter?
No.
It doesn't matter, does it? It's actually, again, just like this previous question, it's just a trick. It doesn't matter what the previous turn was. What does matter is what the proportions are and how they relate to each other, okay? So, for example, here, what is the chance of white winning? It's broken up into quarters, isn't it? So it's 2 out of 4, 2 quarters, good. So white has a chance of a half here, right? 2 quarters. What's the chance of green winning? Well, there's 1 quarter, so that's a quarter, right? So you can see clearly white has a better chance of beating green, but we want the greatest chance, right? So you have to look at the rest of them. You have a look at this one, for instance. Okay, let's have a look. White, 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 that's 3. How many are there in total? 6. So it's 3 out of 6. It's still a half for white, isn't it? What's the chance for green? Well, it's 1, 2. 2 out of 6, that's a third. A third. So comparing just A and B and thinking about green, does green have a better chance here or here? And the answer is over here because the fraction's bigger for green. Okay, so this is tricky. You've got to compare them. I can keep going through. Have a look at this one. Green and white, equal chance, right? A third. And this last one, how many sections are there? There's 5. So that means you got 2/5 and 1/5. Okay, is that right? Did I count them right? Okay, so when you have a look at those, that's why the greatest chance of beating Jim, it does look like these two are equal, right? This one's twice as likely and this one's twice as likely. But A's a better option. Why? There's more space covered, that's true, but there's more space covered for both of them, aren't they? Like, this is bigger and this is bigger, right? A half is bigger than 2/5, but a quarter is bigger than a fifth as well. So why is this one better than this? Yeah.
Well, there's more chance of white winning because it's 2 whites and 1 green, and there's a smaller sample space.
Ah, okay. Now we're getting onto sample space. It does have to do with sample space. Were you going to say something else, Jared?
No, I was just going to say, I got it right, but I got a cross and then a tick that says EW next.
Yeah, that's, you were not paying attention. EW is my initial, so I fixed it. So A is correct. And I initialed it, okay? Alright, now I'll tell you why. This one is a better option than this one. You want it to have you want white to have a better chance of beating green, okay? Now, what's the chance that he beats green? Well, in this case, it's a half minus a quarter. Okay, that's the difference between them. Now, we can do fractions. That's a quarter. Okay, so this is kind of, you could think of this as his advantage. His advantage is a quarter here. Okay, now here, what's the advantage? Well, it's 2/5 minus 1/5. Well, that's 1/5. Now, which of these is bigger? And the answer is a quarter. That advantage is bigger than this advantage. Okay, so even though you could say you're twice as likely to win on white here than green, and you're twice as likely to win here on white than green, but the advantage between them, the gap, is bigger. Okay, so if you like, think about it in these terms, right? Maybe you're watching a game of soccer. Okay, game of soccer, right? And what you've got is one game where one team is beating the other one 2-1. 2-1. Okay, so they've got twice the score of the other team. They're more likely to win at that point. Now, if you watch another game and the score is 20-10, now that team's 10 goals ahead, even though the score is twice as large, right? The gap is 10 goals, right? So therefore, that's why A is a better option. Does that make sense?
Yeah.
Very tricky question. All right, let's keep going. They get a bit simpler. A standard 6-sided die. That's neat. Is numbered from 1 to 6. What's the probability of rolling an even number? You just got to know what the even numbers are. 2, 4, and 6. There are 3 of them, right? So 3 favorable outcomes over 6 total. That's why it's a half. Okay. They didn't ask you to simplify, so that's why either of them would be okay. A bag contains 7 blue, 2 yellow, and 1 green marble, 1 selected at random. What's the probability of not selecting a blue marble? Now, you could count up the yellows and the greens, but it's easier just to say the probability of getting the blue one is 7. So, well, 7 out of 10, sorry, I should say. So the probability of not getting the blue is the rest of the probability. What this is called is a complement, if you remember. We talked about this, right? They're opposite events. Okay, sorry, I got off the page. So this is a simpler way to work it out. Even though if you did yellow, which is 2 out of 10, and green, which is 1 out of 10, you'd still get the right answer. Either of those methods were fine. Over the page. Listed below are all the possible outcomes for a family with 3 children in terms of the gender of the children. Okay, those are all the outcomes. There are 1, 2, 3, 4, 5, 6, 7, 8 outcomes. What's the probability that in a 3-child family there will be at least 1 girl? So you just have to look and think, which one of these, how many of these have at least 1 girl? And the answer is 1, 2, 3, 4, 5, 6, 7 of them have at least 1 girl. Okay, so that's where that 7 comes from. Then you think about how many total options there are. I already counted them up. There are 8. So that's why it's 7 over 8. And you can't simplify anymore. Next one. A coin is tossed, then a standard dice is rolled. The possible outcomes are, so you got your heads and your tails, and then you've got the number that comes on the die. Die. Singular. What's the probability of obtaining tails? Well, you look at all the ones which are tails, right? You could say it's 6 out of 12. But you can just as easily say, look, there's Half of them are here, and the other half are here. So that's why the probability of a tail is just a half. What's the probability of obtaining a tail and a number less than 5? So because they've got all of your outcomes here, your possible things that can happen, you just count up the right ones. I want tails, so I'm only thinking about these bottom ones. Then you want a number less than 5. 1, 2, 3, 4. So that's where the 4 comes from. 4 favorable outcomes. There are 12 total, so you go 4 out of 12, and that's 1 over 3 if you chose to simplify. Okay. Whew. Deck of cards. It's got 4 suits, spades, hearts, diamonds, and clubs. What's the probability that I select a diamond? Okay, now none of these are simplified. Because you've got 4 suits, it's evenly distributed. So you might not have recognized that 52 divided by 4, because there are 4 suits, that's going to be 13. So that's where that 13 comes from. There are 13 of them that are diamonds. You could have even have counted, actually, you know, ace, 2, 3, 4, and so on, but that would have been kind of the slow way to do it. Would have given you the right answer, though, 13 out of 52. Each letter of the word isosceles, the worst spelled word in the history of all maths exams, is written on a card placed in a hat. You even have a nice diagram for you. Then they choose one at random. What's the probability of choosing an E? How many E's are there? 2. 1, 2. And there are 9 letters in total. So that's where your 2 over 9 comes from. John has a bag of 15 marbles. The probability of selecting a yellow one is 2/3. Okay, so that means 2/3 of the marbles are yellow. So that's why he goes 2/3 of the marbles, of which there are 15. And that's where he gets 10. You could go in reverse and check that. If we asked for the probability of yellow marbles, you'd say, well, it'd be 10 yellow marbles out of 15 total. And that's 2/3, just like they told you. So you can check your answer.